So Vin is applied to the non-inverting terminal of op-amp. And what I have done, this is inverting terminal. You know, these are the input terminal. Okay, so let's say this is a non-inverting terminal, positive terminal, and here the voltage at this terminal is, let's say, V1, and voltage at this terminal, let's say, V2. So we are actually connecting input voltage to terminal, first terminal, non-inverting terminal, and we are connecting this output voltage. What is here? Here there is output available at pin number 6. So output and input there. So part of output we are connecting back to the input. So this is the feedback path. And what we will do, we will connect a voltage divider network. So this is a resistance RF, okay, which is connected between output and input. So this I will be connecting like another resistor. So I am drawing here. So a network RF and R1, a network voltage divider network which consists of RF and R1 is connected here, and its midpoint, it's like this. This is your VO, this is RF, this is R1, okay, and the midpoint of this is connected to the input terminal of op-amp V2. Okay, it's the same structure I have drawn here. So I'll also show the load resistance which is connected here. Okay, so the load resistance is connected, RL. Okay, so this is output. Now, where is your feedback voltage available? What we have connected from V2, this is your V2. Okay, so from this point to ground, is your total voltage V2. So what is V2 is voltage across this resistance. This is the voltage across this resistance. Voltage across resistance R1 is connected to V2. Okay, this is your V2. So this point is connected to R1. Look, this point is connected to R1. So voltage across R1 is nothing but V2. So where is the feedback voltage appearing? It is appearing. So part of voltage which is present across R1 is connected to the input. So I will call this as feedback voltage, VF. Okay. So this is our amplifier. So what is sampled from the output? This is output. Okay. The current is flowing. The voltage is developed across R1. So what we have sampled is voltage, and it is there present in the input part. So if you see the input loop, it is in series. The voltages are mixing. So when we are mixing voltages, you know, it's a series mixing. So this configuration is nothing but voltage series feedback. Voltage series feedback. Voltage series feedback. Also show the power supply voltage. You know, op-amp require dual power supply, so plus VCC and minus VEE are connected to the op-amp. Now same thing I will show you by drawing this in different method. So this is your op-amp, okay, and I am giving input to the positive terminal, non-inverting terminal, okay, and this is the negative terminal, that is inverting terminal, and I am connecting a resistance R1 here, okay, and this is the feedback resistance. Output voltage is available here at pin number 6. So between the output and this inverting terminal, I am connecting a resistance which is called as feedback resistance RF. Okay, and this another part end of the R1 is grounded. So if you see this, both configuration are same, both figures are same. Only I have shown here terminal, positive terminal downward, right? And here I have reversed it. Okay, so both figures are same. So RF is your feedback resistor. So this is your this RF. You can verify output to negative terminal. So output to negative terminal, what is their RF? From this negative terminal to ground, what is their RF? So from negative terminal to ground, what is their R1? So voltage across R1 is a feedback voltage, which is going to inverting terminal. Okay. Yeah, I will cut this. So which type of feedback is given? Where you are giving input to the positive terminal. So this configuration is called as non-inverting op-amp. Okay, non-inverting configuration of op-amp. And this is nothing but the voltage series feedback. So remember, it can appear in MCQ type of question. Who is Amit Patil? Is there any person named Amit Patil in our college, in your class?
No, ma'am.
Okay.
Yes, ma'am.
Yes.
ब्रांच चेंज केली मॅम त्याने.
हो का? मी त्याला डिनाय एंट्री केलंय. Okay. Yeah, if you know him, please ask him to rejoin.
Okay, ma'am.
Okay, now let us derive the equation for the gain. Even you know op-amp is a differential amplifier, so we will call the differential gain AD. Differential gain AD. Amit? Amit? Amit Patil? Have you joined?
Yes, ma'am.
Is it your first lecture?
Yes.
Okay. So the gain, you know, gain is always the output. It's a ratio of, if it's a voltage gain, it's a ratio of output voltage upon input voltage, right? Input voltage in case of differential amplifier is nothing but differential voltage. So I'll write this Vi as Vd, right? So the input voltage is nothing but the difference voltage. Now where you have difference voltage, we always measure difference voltage between these two terminals. Okay, this is Vd, differential voltage. It means it is Vd is nothing but the difference between V1 and V2. Okay, Vd is nothing but the difference between V1 and V2. So this Vd is equal to V1 minus V2. But what is your V1? Voltage at this terminal is nothing but what you have connected here, input voltage, Vin. Okay. See, this is terminal voltage V1. I am labeling this point as V1. So what is V1? Actually, we have connected here Vin, input. So your V1 is equal to V in. What is your V2? V2 is the voltage. V2 is the voltage from this point to ground. So what is there? There is only R1. So it's a voltage across R1. Voltage across R1. That is nothing but your Vf. Okay, that is nothing but your Vf. Therefore, I can say Vd, the differential signal Vd is nothing but V1 minus V2 is nothing but V in minus Vf. If you remember feedback voltage, if you remember this, that we have you have an amplifier, you have a feedback network, okay, then this is the part of output which is connected to the feedback network, and we call this as, this is your VO. If this is amplifier, this is the output of amplifier which is going to the input of beta network, and in beta network is providing you the feedback voltage. Okay, we call this as feedback voltage. So this is Vf. Okay, and this will go to the mixer stage. In feedback amplifier, you have a mixer here, and this output of mixer will go to amplifier, and this mixer is receiving one more signal V in. So in this case, what is your beta equal to? Feedback factor beta, it's nothing but the feedback gain. Beta is equal to output of beta network, that is Vf divided by input of beta network, because it's a feedback gain. So it is Vo by Vf. Therefore, you know Vf is equal to beta time Vo. Okay. So I will write this Vd as V in minus beta time Vo. Okay. Now what was our gain? Let's write the same thing in gain. Call this gain equation as 1. This is as 2. Therefore, your gain, differential gain AD, is equal to VO by VD, that is equal to VO divided by V in minus beta time VO. Okay. Now, if I want to find Vf, what is this voltage Vf equal to? The current which is flowing here multiplied by, let us convert this into, you know, if I divide this term by V in, so it will be VO by V in. Okay. This will be V in by V in, and again this will be VO by V in. So what I get VO by V in is nothing but the gain. Okay, so you can get this as A upon 1 plus A beta, A upon 1 plus A beta. Okay, now we want this in terms of this voltage. So let us change it. Okay. This Vf What is Vf? Is the current flowing through resistance R1 multiplied by resistance R1. This is Vf. So current flowing. Which current is flowing? So what is this I? I equal to VO upon Rf plus R1. So this will be VO upon Rf plus R1. So I can write this as R1 upon R1 plus Rf into VO. So this is my VO. Sorry, this is my VF, feedback voltage. Now I will rewrite this equation as VO is equal to AdVd. That is equal to AD into, what is our Vd? V in minus beta time VO. From the same equation I have written this. Let's take VO common. Let it be here. I will continue here. So output is equal to feedback AD into VD. I'll rewrite again. So that is equal to AD into V in minus beta time VO. V minus beta time VO. Okay. So let's take VO at one side. So this will be VO plus. So this AD into beta time VO will come here. AD into beta time VO is equal to AD into V in. Let's take VO common. So it will be 1 plus AD into beta, that is equal to AD into V in. So now arrange this ratio in the form of VO upon V in. This is VO by V in. So this becomes one thing. When I'm AD is the closed loop gain. Differential gain means I have connected feedback. So it's a closed loop gain. Where is my whiteboard? Why I have erased this? Here I have considered this A, right? So this A is an open loop gain. What AD we are finding differential gain, this is nothing but the closed loop gain that is gain after applying feedback. But in this case, where what I have considered here, A is the gain of amplifier without feedback. So this amplifier indicate the gain without feedback. And if I want to find the total gain, then it will be the closed loop gain. So I am considering here the term A, not AD, but I am considering here A. So VO by V in, if I arrange VO by V in, that is equal to A upon 1 plus A beta. The same thing we have found it in feedback amplifier. Okay, feedback amplifier. So what you got, the gain of op-amp when you connect input to the non-inverting terminal is A upon 1 plus A beta. Okay, now this A is the open loop gain of op-amp. From this block diagram, the A indicate gain without applying feedback, and for op-amp we want to calculate the complete gain. So in this case, this is VO by V in is nothing but your differential gain AD, which is equal to VO by V in म्हणजे तुमचा AD आहे, AD differential gain, or you can also call it as closed loop gain, ACL, that is equal to VO by V in, and that is equal to A upon 1 plus A beta, where A indicate the gain of op-amp without applying feedback. So you know the gain of op-amp without applying feedback is very, very high. Okay, A is very high. A is very high. Therefore, this factor A beta is very, very greater than 1. This factor A beta is very, very greater than 1. Okay, that means I can consider here A beta is very greater than 1, so I can neglect this one. 1000 plus 1 is approximately equal to 1000. So A beta product is very, very greater than 1, so I will neglect this additional one, and I can write as closed loop gain ACL is equal to VO by V in is equal to A upon 1 plus A beta is equal to, neglecting this one because this one is small as compared to value of A beta, because A beta will be very large. So it will be A upon A beta. That is nothing but 1 upon beta. तर किती येतोय gain? Closed loop gain of op-amp is 1 by beta. What is beta? Beta is feedback factor. Beta is feedback factor or feedback gain. Okay, beta is feedback factor or feedback gain. Fine. And here only we have find that from this feedback gain. I will enclose it in this green color loop. So we have find it here VF. So what is feedback gain? Feedback gain beta is nothing but output of beta network, that is VF upon input to beta network. So if you arrange this by VO by VF by VO, it is nothing but your beta. So what is this? R1 upon R1 plus RF. So this is your beta. So I can use this value. What is our beta? R1 upon R1 plus RF. R1 upon R1 plus RF. Okay. Therefore, what is the gain? The closed loop gain of op-amp is equal to 1 upon beta, that is 1 upon R1 plus RF, that is equal to Vaibhavi, why you joined so late? Okay, so that can be written as ACL is equal to R1 plus RF upon R1, can be written as R1 upon R1, which is 1 plus RF by R1. So this is the closed loop gain of op-amp when you are applying input to the positive terminal. So you can also remember this as the non-inverting configuration. Non-inverting configuration. Non-inverting configuration. And which type of feedback is used here? Voltage. We have sampled voltage and we have mixed the voltage, means series mixing. Voltage, series, feedback. So what is the gain of op-amp? I will ask you in the two way. What is the gain of op-amp for non-inverting configuration, or what is the gain of op-amp with voltage series feedback? So answer of both is ACL is equal to 1 plus RF by R1. Got it? So remember this, and what you can conclude whenever you see such diagram, it means voltage series, because what is present, what feedback you are taking? Voltage across R1. What you are mixing at the input? You are mixing input and this. Okay, because VD is the difference between these two signals. So voltage mixing is happened. So it is a voltage series feedback, and in this case the gain of op-amp is 1 plus RF upon R1. Remember, when we will derive it for next, it will be only RF by R1, and there if you will see that we will apply input to the inverting terminal. Okay, now हेच गोष्ट मी तुम्हाला अजून सांगणार आहे in the different way which you will learn in next unit. Okay, but I will tell you immediately here, whatever configuration of op-amp I have drawn, the same thing I am drawing. तीच गोष्ट मी पुन्हा काढते, same thing I am drawing. Are you getting? Please remember how is the configuration, what is the method of finding this. So let's have op-amp. Always draw here, because if you don't show this, it means your op-amp may not work. So sometimes you draw the complete circuit diagram and forget to show you. So examiner can ask you, your circuit is not working, and you will say the entire circuit is correct, then what is the problem? So remember, if you don't show power supply, it means it may be treated as an inoperative circuit, because unless and until you apply power supply, it will not work. Okay, now for convenience, I will show here minus and this is plus. So in the previous diagram, look at the positive terminal. What I have done, connected input signal. So same thing I will do here. So I will connect here input signal V in. And what I have done with negative terminal. So between this negative terminal, that is inverting terminal, and output, I have connected feedback resistance. So let's connect. So I will connect here a feedback resistor. Okay. So this is RF connected between output terminal and input terminal. What I have done here at this terminal, I have connected one more resistance R1, and then I have grounded it. So I will show that resistance here, R1. So this is V1. Let's say now I will call this as V2. This is V1. Sorry, I got muted. Okay, so now this is the part I am showing from next unit. But as we have just now seen voltage series feedback and we got gain equal to किती मिळाला gain आपल्याला सांगा? How much was the gain of this circuit when we apply input to the positive terminal and we provide voltage series feedback? So how much gain we obtained? Everybody? How much gain we obtained? Yes?
1 by beta.
That's value is, we have calculated it in terms of what is that 1 by beta comes.
1 plus RF upon R1.
R1.
1 plus RF by R1. Okay. So remember, now what I am doing. Op-amp, yesterday we have seen the current drawn by op-amp, we indicate it as IB1 and IB2. So let's say this is IB2 and this is IB1. And op-amp ideally draws zero current. So IB1 equal to IB2 equal to 0. Okay, IB1 equal to IB2 equal to 0. Op-amp does not draw ideally any current, practically very, very small negligible current. Okay, now this is input connected at non-inverting terminal. It's the output voltage. So, and this is a ground terminal. Op-amp is not drawing any current. So you can see how the current will flow. Current will flow like this to the ground. Okay, so what is this current? You can calculate this current as VO upon RF plus R1. Our current किती आहे? VO upon RF plus R1. Nothing is going inside. Okay. Now let us apply Kirchhoff's current law at this node A. Call this node as node A. And call this node as node B. So let's call this current as I1. Current which is flowing through R1 is I1. Current which is flowing through RF is IF. Okay. So apply KCL at node A. Tell me. Apply here KCL. Look at node A. What are the incoming and outgoing current here? Look at node A. Please unmute.
IF minus I1.
IF is coming toward here. I1 is going out. So first of all, I'll write what are the incoming current IF and what are the outgoing current. So IF is equal to I1 plus IB2. Okay. But as IB2 is 0, IB2 equal to 0, therefore IF equal to I1, right? IF equal to I1. So now let's find this current. Okay. So what is IF? Let's find current IF. So this voltage here is VO, okay, and voltage present here, as this as I'm calling as node A, let's say it is VA. So IF is equal to, this is the direction of IF. Okay, this is direction of IF. This is direction of I1. So this is IF and the green one is I1. So this voltage minus this voltage divided by RF. So if you apply KVL, you can find it. So IF is equal to VO minus VA divided by RF. Okay. Now, yesterday we learned one concept called as virtual short and virtual ground. Do you remember that? Virtual short and virtual ground. Do you remember that? See, I told you, I am relating your further op-amp applications with whatever theory we are learning. So in this section, we seen what is a voltage series feedback. Okay, how we are sampling voltage, how we are mixing in series. And in this case, we are giving input to the non-inverting terminal. So whatever gain we got, the same thing we will get here with this circuit. Okay, but I am deriving it by some different method. Remember, in all op-amp application, apply KCL at this point and you will get the solution of most of the problem. Okay, so yesterday we learned a concept of voltage short and virtual short and virtual ground. So do you remember what is that? Student, please do not repeat yesterday's episode again. Virtual short.
Yes, ma'am.
What is that? Anybody can tell what is that virtual short?
V1 equals to V2. So
Correct. According to concept of virtual short, I'll write in text. According to the concept of virtual short, what is there? V1 is equal to V2. V1 is equal to V2, right? Now here, what is V1? Yes, here V1 is nothing but VA. हा V1 आहे, but I labeled it as VA. एक टर्मिनल म्हटलं म्हणून मी त्याला VA म्हणते. So this is here V1 is equal to V2. V1 equal to V2. Sorry, here V1 is equal to VA. V1 ला काय म्हटलंय आपण? VA म्हटलेलं आहे. Okay. And what is our V2? Sorry. I have changed the notation here. Here I have said V2 and here I have said V1. So VA, जर मी इथे V1 लिहिते आहे तर V1 मी इथे दाखवलं. I have shown V1 here. So V1 is nothing but V in. Look here. Please look here. Look here. This is V1 and to this terminal we have connected V in. So this voltage is nothing but V in. So here VA O V1 is not it. V1 is equal to V in. And what is V2? V2 is equal to VA. I can also say that VA is equal to VB because याला V1 पण म्हटलं आणि terminal B म्हटल्यामुळे I can call this as VB also. So V1 is nothing but VB is equal to V in because directly I have connected input voltage there. What is V2 is equal to VA. Now, according to the concept of virtual short, V1 equal to V2, therefore, V in here, V1 equal to VB equal to V in and V2 equal to VA. So, by concept of virtual short, V dot S I will write, VA is equal to V in, बरोबर. या टर्मिनलला V in व्होल्टेज कनेक्ट केलेलं आहे. सो या टर्मिनलचं व्होल्टेज V in आहे आणि इथे अकॉर्डिंग टू कन्सेप्ट ऑफ व्हर्च्युअल शॉर्ट जे एकाच आहे ते दुसऱ्याच असणार आहे. सो VA इज व्हर्च्युअली ऍट V in. So VA is equal to V in. Therefore, what is my current IF? Look at. Have you understood this? Actually, V1 काय आहे? What is V1 actually? It is nothing but V in. Okay. Because I am calling this as B, terminal A and B, so I can also call this V1 as VB. So the voltage at this terminal is V in, therefore virtually the voltage at this terminal at point A is also V in. Therefore, I can write IF is equal to VO minus this VA I am going to replace by V in divided by RF. Okay. Now, what is I1? हा तर IF झाला. Let's find I1. What is I1? What is I1 is the current flowing through this branch. So the voltage at this point is VA. Voltage at this point is 0. So I1 is equal to VA minus 0 upon R1. But what is our VA? That is equal to V. Just now we have seen. So this is equal to V in upon R1. So what this, let's make this equation as 2 and this as 1. So what is our equation 1? IF is equal to I1. But according to 1, IF is equal to I1. Just let me initiate your attendance. Attendance started, please mark it. But don't leave the meeting. Okay, so IF is equal to I1. What was our IF? VO minus V in upon R1. Therefore, VO minus V in upon R1 is equal to V in upon R1. Right? Sorry, in IF it is RF. Okay. So one can solve this. VO minus V in is equal to, let's take this cross multiply, RF upon R1 into V in. So let's take this as VO is equal to RF upon R1 into V in plus V in. So let's take V in common. It is 1 plus RF upon R1. Therefore, I can arrange this as VO by V in is equal to 1 plus RF upon R1. So what is the gain of op-amp in non-inverting configuration? 1 plus RF by R1. तीच गोष्ट आपण एका दुसऱ्या पद्धतीने पाहिली, ही परत पाहिली की in non-inverting configuration you are applying input to the non-inverting and you are grounding inverting terminal through the resistor R1. So in all the application you have to follow same process. Okay, consider this as point A, this as terminal A, this as terminal B. Voltage here you can consider V2 and V1. Okay, and apply KCL at this point. So what you get is I1, the I1 plus IB2 is equal to IF, but IB2 is 0. Therefore, I1 is equal to IF. Now find value of IF. What is that? VO minus VA upon RF. Okay. But what is VA? Our voltage at our VA is equal to V in. Therefore, V2 is also equal to V in as from the concept of virtual short. Therefore, replace VA. You can call this either VA or V2, whatever you find simpler. No need of using two things. So this VA can be replaced by V in. So you get this expression for IF. Similarly, you can find IF as the voltage at this point minus this ground divided by R1. Equate this two and arrange it in the form of gain. So this is the gain of non-inverting configuration of op-amp. ह्या सगळ्यांनी लक्षात ठेवायचं आहे. You have to remember it permanently. Similarly, you can have voltage shunt feedback. Now, voltage shunt feedback, before drawing this diagram, let me explain you the same thing here. What I will do, I will apply output to this terminal of and very fast we will derive this expression. You only will tell me the steps. लक्षात ठेवा. Now, this is your R1, you know, and we will give input to this. Let's make it as inverting, and this is a non-inverting. So input V in is given to inverting terminal through R1. In this case, ground this terminal, non-inverting terminal, and connect the feedback here through RF. Okay, this is your VO. Now, let's call this as V1. Let's call this as V2. No confusion. So, now you have applied here. Okay, so this is the current flowing I1 and this is the current flowing IF. So can anybody tell me? Let's say this is IB2 and IB1. Okay. So IB1 and IB2 both are 0. Apply KCL at point A. Tell me. Yes, apply KCL at point A. Tell me what are the incoming and outgoing currents. Yes, what are the incoming and outgoing currents here at point A?
I1 equals to IF plus IB2.
I1 is equal to IB2 plus IF. But IB2 is 0. Op-amp is not drawing any current, so I1 is equal to IF. Okay, let's call this as equation 1. Then what to do? Find what is I1. What is I1 and what is IF? What is I1? Voltage at this point. You can call it as VA. So this voltage minus this voltage minus this voltage. Okay, current is flowing in this direction, so it is V in minus VA divided by R1. Okay, and what is IF? This is the direction of current flowing IF, so this voltage minus this voltage. So IF is equal to VA minus VO divided by RF. Okay, what is your concept of virtual short? Virtual short and virtual ground. Okay, now see, according to this concept, V1 is equal to V2. Now here V1 is equal to 0 because this terminal is grounded. Therefore V2 is also equal to 0. So let's call this as 2 and this as 3. Okay, therefore yeah, I put it now. Your equation 1 will become I1, which is V in minus now VA shall be replaced by 0 because VA is equal to 0. That is V2 or VA equal to 0. Therefore, V in minus 0 upon R1. Your equation 1 is going to turn V in minus 0 upon R1 is equal to VA पुन्हा 0च आहे. So 0 minus VO upon RF. Okay. So V in upon R1 is equal to minus VO by RF. Arrange this ratio. What is gain? The closed loop gain of op-amp is equal to output voltage upon input voltage VO by V in. That will be minus RF upon R1. So this is the gain of op-amp in non-inverting configuration. This is the gain of op-amp in non-inverting configuration. Okay. So I will take the names of only those students who are not tick marked because right now I have initiated the attendance. Everybody mark the attendance.
Ma'am, the timer has been run out.
But I have initiated it before, na? Before 5 minutes today I have initiated it. It's 21st. $36 student has marked. Those who have not marked, please tell me. Parth Vaviskar,
Present, ma'am.
Simarpreet Chawla, Those who are having tick mark, they can leave. Simarpreet Chawla, Ruturaj Cholke, Kalpesh Deshmukh,
Present, ma'am.
then Abhishek Kanade, Varun Naikre,
Present, ma'am.
Prathamesh Patil,
Present, ma'am.
Samruddhi Patil, Aditya Pawar, Piyush Savkar,
Present, ma'am.
Suyash Thapure, Suyash, Shubham Shrisat, Tejas Sonavne,
Present, ma'am.
Akshay Sutar.
Present, ma'am.
Fine. No new student entry is not there. So you please talk to the ERP coordinator, Amit Patil. So
Yes, ma'am.
you can leave the meeting now. I'll check the chat box if anybody is there. No one has written.